Yes. Okay, so... Okay, thank you. Oh. Hello, good morning. My name is Andrea Aime. I work for GeoSolutions, and I'm going to talk about map styling in GeoServer. So GeoSolution is an Italian company founded in 2006. We have expertise in various topics, but of course we have a strong one in GeoServer. And well, we work on a variety of things like raster data, vector data, we set up custom applications and the like. I invite you to go and have a look at our website to get more information about the company. So, as I said, this presentation is about styling maps in GeoServer. I'll first do a quick tour of the styling languages. When you think about GeoServer, you probably think SLD. But nowadays, GeoServer has a pluggable styling language system. And we have, while we have SLD as a core default language, it's possible to use other styling languages as well. So we also have GeoCSS, YSLD, MBStyles, which is Mapbox. They are all syntaxes that are parsed and turned into an internal object model, which then feeds the renderer. So we have one map renderer that can be driven by several different ways of specifying the styling. As a result, all the styling languages share the same concepts because they all have to go towards the same object model. So every styling language has layers. The layers are made of rules. The rules have a filter selector that decides what features get rendered for that particular rule, scale dependencies eventually, and symbolizer to depict point, line, polygons, and labels. SLD 10 and 11 are the only OGC standard languages that we support. They are XML based, they are verbose, hard to hand edit. To give credit to OGC, they weren't meant to be hand edited, they were meant to be machine generated and machine read. But the history chose otherwise. We didn't make a good UI to edit SLDs in GeoServer, and people just started editing them. There are several external tools that can use to generate the SLDs. The interoperability is sometimes limited, and you have to fall back to hand editing to tweak them the way you want. Here is how an SLD looks like. As you can see, XML document, and there are the concepts that I was talking about. It starts with a filter. Let's render all points whose type is alpine hot. Let's limit the scale, the visibility to scales with a denominator less than 100,000, and we are going to use that particular PNG as the symbol that will be rendered. So I've omitted at the beginning and at the end quite a bit of extra boilerplate XML, but you get the idea. It's a kind of quite heavy way to describe how the map is going to be rendered. Very closely related to SLD, we have YSLD, which is basically SLD but using YAML syntax instead of XML. By going to YAML, we get quite a bit less boilerplate. The filtering is defined in a more human-readable way. That's CQL, catalog query language, which, if you're not familiar with it, think SQL, the where clause of an SQL query. That's how the syntax you use. The scale is more compact, and also the part about the symbolization is more readable. But we still have quite a bit of boilerplate around to identify the points that we have to render. Let's move to GeoCSS. GeoCSS is a CSS-inspired language. It's not exactly the CSS you use for web pages, but it uses the same syntax and the same concepts. So we have selectors that identify which features we want to render. type equals alpine hat. That selector is a filter, and it's written in CQL again. We have the scale dependency there, and scale denominator less than 100,000, and we just point to the symbol that we want to use. So in 3 lines, we achieve the same result as that long page of XML. So it's the most compact language, although sometimes people get confused by the cascading part of CSS, how the rule mix together. Finally, in GeoServer, we support Mapbox.gl. This is a whole different animal. This is a whole different beast. Mapbox.gl is a language that has been defined by Mapbox for styling in web clients. It normally styles vector tiles. And let's say that you want to make an application that uses vector tiles, but you need to also provide a fallback to an OGC recognized standard and to server-side rendered tiles, because maybe you want to also talk to clients that cannot do vector tiles, you know, for interoperability purposes. GeoServer thus supports this language also on the server side. So you have a fallback. You normally do vector tiles and client-side rendering, but if a client needs classic PNG tiles, you can use the same style on the server side. This is how a Mapbox style look like. As you can see, it's a JSON file. The scale dependency is specified as zoom levels. So this styling language only talks about zoom levels of Web Mercator. There's no way to say 1 to 1 million. Don't even think about it. The filter is painful, in my opinion, because it's written in postfix notation. So you say equal type alpine hat, and I'm like, what? And I mean, I studied computer science, and postfix notation parser was one of the first exercises in the first class of computer programming. I think that it could have done it better, but it's just my opinion. And then when you want to refer to a symbol, you use a name inside a sprite file. If you are familiar with game development, sprites are images that contain many sub-images, and you refer to one of them. This is sort of an optimization which is very good for the web, but again, it's a bit strange. So what's next? We have seen the syntaxes, we have seen the languages, now let's see the concepts. And I'm going to show you examples in one of these 3 languages to go along with the concept. So let's start with scale dependencies. It's kind of the simplest filter you can think of. What type of scale dependencies might you have? Well, typically 2 kinds. The kind that makes things appear and disappear depending on the zoom level, like I zoom in on this map, buildings start showing up, they weren't there before, or vice versa. I might hide stuff as I zoom in because it's not relevant anymore. Like I zoom in and I don't see the country borders anymore or stuff like that. Or I can change the way I visualize the features depending on the zoom level. In this case, I'm making a line thicker as I zoom in. So I change the way things are displayed. How do I express a scale dependency? I do it by specifying the scale range in which a certain thing should happen. So in SLD, there are the min and max scale denominator element. In YSLD, I provide a range between 2 numbers. For readability purposes, you can also use a scientific notation, assuming that you can read easily scientific notation. I sometimes have trouble with it. Or you can specify zoom levels and a grid set in case you are thinking in terms of tiles and zoom level of a grid set. If you do CSS instead, there's this variable called SD, which is the scale denominator, and you just express it as if it was a filter. So that says scale denominator must be more than 1,000 and less than 1 million. As you can see, there are suffixes that you can add to specify the quantity. I did it because I'm the maintainer of the CSS language, so I'm biased. I did it because every time I look at something like 1 million, I'm wondering, is that 100,000, 1 million, or 10 million? And I have to count the 0. So I wanted to have a very explicit way to look at the number. So say that you want to instead change the appearance and in particular make the line thicker as you zoom in. How do you do it? Well, one way is to stop specifying the sizes in pixels and do it in meters instead, or feet, or some real-world unit. When you say the line is 20 meters thick, the render will automatically make it larger when you zoom in and smaller when you zoom out. So how do you do it? These are the three syntaxes for SLD, YSLD, and CSS. They are progressively more compact. So in SLD, you have that long URI. At the end, there's meter. In YSLD, they just preserve the meter, and in CSS, you say 5 meters, 5M. Another approach that you can use if you have a non-linear dependency, like you don't want to, you wanted to have, let's say, different values at different zoom levels, but it's not proportional, you can specify a categorization and say something like, depending on the scale denominator, let's make the lines less than 2 pixels at less than 400,000, 1.9 pixels at between 400,000 and 800,000, and so on. This example is not made up. It's a straight copy of what OpenStreetMap does. So you might think it's convoluted, but you see it every day. This is the version in CSS, and that's the equivalent in SLD. The function is the same. It's called categorize. It's just that, yeah, again, big numbers, difficult to figure out if those are 1,000, millions, or what they are. So that's it for scale dependencies. Let's switch to point styling. How do I style points in the various languages, and what capabilities do I have? Well, the simplest thing that we have already seen is to use a small fixed image where the point is. And we already seen this example before, so I'm not gonna spend much time on it. Another thing that you can do is to place a shape. So instead of saying, okay, this is the image, take the contents as is. You cannot change the colors, you cannot change the size, it's as is. What if I wanted to have more control? Then you can use a mark. A mark is just a shape. It's a square, it's a circle, or in this case, bills. And then you can specify the color of it, the contour of it, and so on, and rescale it so it's much more flexible. Of course, you have to do a bit more work because you have to specify how you want to fill it, what size it is, and so on. Now I have two examples doing the same thing, taking this bank.svg and filling with a certain color and making it 14 pixels big. In CSS and in YSLD. I will not give you the SLD syntax because it's gonna be too long. Sometimes you want to do different symbols and maybe complex symbols. So this is another example taken from OpenStreetMap. OpenStreetMap depicts public fountains as two superimposed circles when you are zoomed out and as an icon when you are zoomed in. So that's an example in CSS of how to do it. When type is fountain and the scale denominator is less than 6,000, then do two circles. One is dark blue, the other is light blue. One is 10 pixels big and the other is 3 pixels big. So this is symbol composition. I'm putting together two symbols to make a complex one. However, if the scale denominator is less than 3,000, then forget about it. Let's use this SVG and fill it in blue. As you can see, I've said a lot of things in a relatively compact way using CSS. GeoServer provides a lot of other mark options. I'm giving you a link to the guide because there are too many. That would take a presentation of its own. Yeah, let's move on. So how do I fill polygons? The simplest thing that I can do is to fill polygons by filling them with a solid color. In CSS, you just say fill light gray, done. And well, I also stroked it a bit. In SLD, it's similar. It's just that you have so many more extra things to type. You can also fill with repeated images. This is, again, a complex example. This is a composition. These are cemeteries. I want to make them green, okay, but then I wanted to put on a symbol, identify the type of cemetery, Christian, Jew, or generic. And, well, the filling is at the top. If the type is cemetery, then make it green, and then if the scale denominator is small enough, then let's add on top of it the crosses. And depending on the religion, I'm going to use a different kind of overlay. The same in YSLD is quite a bit more verbose. It's 2 slides worth of syntax doing the same thing. The first part says, let's make it green, and then the second part here, well, you don't see it, but says, okay, if we are zoomed in enough and the religion is Jewish, let's use this symbol. If the religion is Christian, let's use that symbol. If it's generic, another one. So again, different syntax, different level of verbosity. You can do hatch filling as well. In GeoServer, it's done by repeating small symbols that, if lined up, form the hatches. So in this case, I have a times symbol, which is a cross, actually. If I put many of them together, it generates this hatching effect. In CSS is, again, quite compact. I specify the symbol, the size, and the color. And, well, in SLD, I do the same things, just with more words. Say I want to switch to lines. The basic thing is to do solid lines. This is, again, an example taken from OSM. The borders, the administrative borders show up at different zoom levels, depending on their type. So country borders show up before, region borders show up later, county borders show up later again. In CSS, you do it by providing alternative filters. So if the update level is less than 4, or if the update level is 5 or 6, and the scale denominator is less than 400,000, or blah, 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 then apply that border. Again, it's like putting together a number of rules in a very compact way. In SLD or YSLD, I would have had to create 1, 2, 3, 4 different rules and repeat myself about the styling. It's also possible to make non-continuous dashed lines. Again, in CSS, you can just do it by specifying the stroke dash array property. It's 2 pixel pen up, 2 pixel pen down, and so on, so that you generate a dashed line, which is the trails over there. And if you want, you can also alternate, repeat symbols along the line, and maybe alternate lines with circles, like in this case. I'm just saying, okay, let's make the line dark red and then a circle. I want to use dash arrays, and I will make it so that when the line disappears, the circle appears, and vice versa. No vector map is done without labeling, or very few of them. Labeling is a complicated topic. GeoServer has a ton of vendor options. Because SLD doesn't give you much control of how to place the labels and how to treat them. So GeoServer has a very long list of vendor options to control how you want to place the symbols. Let's have a look at some example. This is a CSS example. At the top, we are saying, okay, let's pick the full name attribute. We are going to position the label below the symbol. We are using a certain color. We are using a halo to make it stand out of the background. We are giving a priority, and I'm saying, please auto-wrap the label if it's too long. Wrap it in multiple lines. And then I place also a symbol below it. I can make the symbol a label obstacle so that labels will not overlap with the symbol, which is at the top without the rule to make it an obstacle, at the bottom making it an obstacle. Of course, the second map says less things, but in a more readable way. Labeling lines is complicated topic. Again, this is an example of a simple map. We have the same things as before, but then we are saying, let's follow the shape of the road. So you can see a few curved labels. Let's repeat the label every 400 pixels in case the road is really, really long, and group together pieces that have the same label so that they are labeled as one, because sometimes roads are split in many, many little elements. Finally, for polygon labeling, which is kind of one of the simplest, this one I did in SLD, more or less the same things. GeoServer will place the labels in the centroid of the polygon. Okay, let's also have a look at the raster styling. So rasters come in two type of sources. You have the raster surfaces, in which each pixel contains a value. A digital elevation model is such type of surface. Each pixel contains an elevation, and normally you want to associate it with a color, and you do it with a color map entry. You make several associations, and GeoServer will depict every intermediate step using interpolation. In GeoServer 2.14, we are also going to add a shaded relief, so that it will give some more depth to that kind of map. Another type of source is the one that contains a color, or at least the amount of light emitted in a certain wavelength. I'm talking in this term because there are so many multispectral imagery nowadays available. I'm thinking Sentinel-2, for example, which has 13 bands. So you normally take them, and you do some contrast enhancement to make them, you select a few bands out of the 13, you do some contrast enhancement to make the map easier to display. There are a number of other assorted features in GeoServer that I'm just going to go over quickly. So far we looked at a single layer, but a map is normally made of several stacked layers. So we have ways to compose them. Instead of just painting over what was there before, we can have color blending. And when we superimpose those two, we can specify different types of color blending to achieve a nice effect. Like when you do shaded relief using multiply, normally makes the map look a lot better than just alpha blending, for example. In this case, we are doing masking. So I take that map, I take that mask, and basically preserve only what's inside the black to generate this kind of effect. And we have several type of compositing that can generate different type of effects. Z-ordering is very, very important if you do any kind of roadmap, because there are overpasses, underpasses, tunnels, and whatnot. You want to draw the lines in the right order to respect the order of the real world. This is a real crossing in Germany. I don't know how they did it, but somehow they did it. And if you try to style it the wrong way, it's going to look like a mess with the bridges going below the roads and stuff like that. In GeoServer, we provided this notion of sort by. So we are basically sorting the features before rendering them on the map. And you can sort by whatever attribute you want, or multiple attributes if you want. In this case, the OpenStreetMap already has a Z-order indicator in its dataset. Another nice thing that we have in GeoServer, it's the notion of geometry transformations, which, if you are familiar with QGIS, is close to geometry generators, so that you can take a geometry and apply a function, turn it into something else. In this case, I'm applying a very simple offset to generate a drop shadow effect. If you're not happy with this level of transformation, you can push it further and say, okay, let's take the entire dataset, the entire layer, and transform it into something else before rendering on the fly. This is a case in which I have digital elevation model, and I have extracted on the fly contour lines and then depicted them as such with the values and so on. the machinery is really, really optimized, and it can be used for interactive rendering. New in GeoServer 2.14, we have the ability to also do raster algebra, which is interesting if you are into Sentinel-2, Landsat 8, or multispectral imagery in general, or drone maps, or something like that. This is an example of taking a Sentinel-2 image and computing NDVI on the fly, which is a vegetation index. The green parts are a good vegetation in good state, red not so good, pink it's water actually. Okay, let's say that you listened to me so far and said, this is bullshit, I don't want to hand edit all the stuff, not even in CSS, no way. What you can do if you wanted to use an open source tool to make styles, you could use QGIS, especially in version 3, the rendering, sorry, the export has been improved significantly. That's one map rendered by QGIS and then exported the SLD, and the same map as rendered by GeoServer. We still don't have export for raster styles. We cover only the vector symbology is covered. But OSGeo UK has gave some sponsorship to the GeoServer PSC, and we are now looking for proposal, thus people that want to use that money to implement some improvements to the QGIS export abilities. And hopefully it will be exporting of rasters. And that's it.
Is there any quick question to Andrea? So I guess not. You can catch him in the corridors afterwards, but I think we're going to have coffee now. And when do we need to get back here? Does anybody know?
Hi, according to the program, I already have a 5 minutes talk. Therefore, I give you 10 minutes for the coffee and cakes and come back in 5 minutes past 11:30.